In this video, I'm going to show you how to calculate the instantaneous velocity of a position versus time graph. Okay, so if you look at this red line here, this is a position versus time graph, and the slope of this line, the slope of this thing is the velocity. Okay, but the problem that we have is that the slope is continuously changing. That's a problem, right? So if somebody says, what is the velocity, let's say 6 seconds right here, okay? It's kind of hard to find the slope because it's only that slope for just that little bit, and after this it's a little steeper, and before it's less steep, okay? So what we're going to do is we're going to use a trick here, okay? There's a rule in math that says that if you draw a tangent line at a point, like that blue line there, okay, the slope of the tangent line is the same as the slope. So the slope of the blue line is the same as the slope of the red line at that instant, okay? Now you have to draw the tangent line correctly. So in this case it looks symmetrical, right? It looks like it actually only touches in that one point, and it looks like it actually has the same slope, right? It's a tangent line. Like for example, this would not be a tangent line, okay? This is not a tangent line, okay? It's got to like just sort of nuzzle up against it. And sometimes kids have a hard time, drawing tangent lines. That's something we'll practice, okay? Now, if I had my draw, there's this line to be just a little bit longer. Okay, there we go. Because it needs to intersect some grid lines, okay? Now, the cool thing is that this blue line is a straight line, and we know how to find the slope of a straight line. What we're going to do here is we're going to read off the coordinates here and here, and we're going to use the fact that the slope, the velocity is going to be the slope, right? And that's just going to be y2 minus y1. There's a form of the slope, right? This is called the point form or something like that, right? If you have 2 points, and this is all this is just rise over run, okay? Rise is how much the x changes, and run is rise is how much the y changes, and run is how much the x changes, okay? So what we have to do is we have to read off these points, okay? So that point right there, we want to figure out what its x and its y, right? Because this is going to be x2 and y2. Okay, and by the way, the 1 and the 2, 1 happens first, 2 happens later in time. Okay, so this is x2 and y2, okay? Now, x is easy because this is 5, 6, 7, 8, 9, okay? So this is 9 seconds over. That's easy. One of them's always easy. It's on a grid line, right? Okay, but the y we're going to have to read off of here. So this is 5 meters here. That's 6 meters, right? So 5, we're a little more than 5, right? How much more than 5 are we? I don't know. 5.2 is my guess. I'm going to say 5.2. 5.2 meters. Notice I'm using the units. So this is seconds is our x. Our y is actually in meters, right? It's kind of weird. Okay, so again, you just have to read off. You just have to do your best. Okay, now if you said it was 5.3, that's fine. If you said it was 5.1, that's fine. If you said it was 5.5, I would argue with you. Okay, it's definitely not halfway between, right? All right, let's take a look at this guy here. This point right here is how far over? I'm going to put the coordinates here. Well, that's easy. 1, 2, 3. Looks like it's right on 3, right? So 3 seconds over. And then how far up? Well, this is 0, right? So it's 0 up, okay? So it's 3 seconds over and 0 meters up, okay? 0 is the easy one, and then we just happened to land on a grid line, so the x was easy. So now we're just going to do this, right? So our velocity is y2 minus y1. So here's y2, 5.2 minus y1, which is 0. Okay, and this is meters, and that's meters. And then let's see, it's going to be x2 minus x1. So x2 is this guy here, right? So 9 seconds, right, minus x1, which is 3 seconds. Okay, so let's put this in the calculator. Now, when you do it in the calculator, unless you actually use the fraction, the fraction function, you do need to use parentheses, okay? So I'm going to go left parenthesis 5.2 minus 0. I know that's stupid, but okay. Divided by left parenthesis 9 minus 3 right parenthesis, enter. And I get 0.8666. So I'll go 0.87. Now, don't freak out. If you get like 0.85, I think the last time I did this, I got 0.85 or something like that. We're going to be in the ballpark, though, right? We're going to be in the ballpark. Obviously, since we're reading the graph, and we're only people, right? We're only human. We can make little mistakes. We don't want to make big mistakes, but we can make little ones. So again, what you want to do is if they ask you for the velocity at a certain point, you put a tangent line in that's tangent right at that point, okay? Then you read off the x and y coordinates of the end points. You don't want to do something really close to there. I'm not even going to use that point. You want to use the points that are the farthest away. That'll introduce the least amount of error into your calculation of the slope. You just read those coordinates, stick it into here, and you'll get the slope.